Okay, hello everyone. So today I decided to record myself live while solving the starters 121 contest. And at the start, the currently when I'm solving the stream will be private. And if the contest goes well, I will make the stream public so you can hear my thoughts. So you can see how I solved all the problems. Okay, that I will solve during the contest. Now, uh, even I am still learning, so I don't know how many problems I will solve. And so let's see how the contest goes. And we still have 3 minutes remaining, so I will just show you my setup till then. So I will use open board while solving the contest. And okay, so and VS Code for coding purpose. And still we have 2 minutes remaining, so I will be the extensions that I will use are, one is the competitive companion, and in my VS Code I will have two extensions. One is the CPH judge extension for importing the test cases, and competitive companion. Okay, so we have this now. I mean, I can code in both languages, Python and C++, but I will prefer, I don't know in which languages I will use. Mostly, I think I will try to code more in Python because the code will be much shorter. And because I will be talking while talking in the mic while solving problems, so my speed will be slow, I think. But let's see how the contest goes. Okay, we still have 2 minutes remaining. Let me check if the audio is working fine or not. So, so okay, okay, I think the audio is fine. And can we actually? I don't think I should stop remove this. Okay. Okay, we still have 1 minute 16 seconds. Okay, someone asked me about the debug template. So what is the debug template? It is a simple template that I use for competitive programming. It is these lines of code basically, and if you have some variable, let's say int x equals 1, then if you write debug x, then when you run the code you can see this in separately what was the value of x at that time. And while submitting the problem you don't even have to remove these lines, so there will be you will be able to see the value of x and the name of the variable uh, when your was running, and you don't even have to remove these lines before submitting, so it will just work because it is in the error logs, not the your received output. So if you have something like pair intent y is equals to 102 comma 103 and you say debug of y, uh, then it will also work. So yeah, you have this. So that is my debug template, and let me connect my pen tablet also. Okay, contest. I think I am late. Okay, you are given an array A of n elements. In one operation, you can swap any two elements if they are not adjacent. That is, you can pick two indices I and j such that okay, and swap I and j. Using this operation finitely many, possibly zero number of times, is it possible to turn A into a sorted array? Okay, and n is only going till 1000, so we can actually do this in big of n square. And okay, I think we can do it in brute force manner. Like first I can sort the whole array, and then I think I can just do it in brute force. I don't even need to think much about it. So let me do it in Python because the code will be much shorter. So first I think we have an integer, so int input. Then we have the array, so list map int input dot split. Yeah. For now I don't need my pen tablet, so yeah. Okay, now we have this. So what should I do now? First I'm going to do is, first I'm going to just uh, first I'm going to say a dot, let's make a copy of a and sort it. So c a dot copy, and b dot sort. So now my b array is sorted, and now for I in range n, for j in range, I think I'm just doing some kind of bubble sort. So I plus 1, because I want to have at least, uh, what should I say, at least one space between them. I think maybe I can just copy it from GFG. I don't know. I think we should just copy it from GFG, bubble sort. So because I don't want to make any mistakes during live stream. So the code goes like, okay, we have this for j in range this. Okay, so we have j in range 0 to n minus I minus 1, and I is from 0 to n minus 1. I think I will just say, let's just copy this whole thing. Yeah. So we have for I in range n, swapped equals false, and j in range I. First thing we have, if I minus j is less than equals to 1, then continue. And I think the rest will stay the same. So I can make this ARR and ARR. Okay. After this, my array should be sorted. So now I just need to check if it is sorted. So for I in range n, if a of I, or I can say array of I not equals to b of I, then let's have a check variable, or I can simply print no, and return out of this function, else I will print a yes. So we are getting some wrong answers. Yes, no, yes. Okay, let's print array and b. Let's say absolute value. Okay, uh, I think this is the case where it was failing, and then we are still getting yes, no, no. After this whole loop, like array of a, absolute value of I minus j should be mm, greater than 1, such that if I minus j greater than 1, then only okay, for I in range n, for j in range 0 to n minus I minus 1, I think let's go till n minus I. Array of j, we are swapping them, and let's go till for j in range n only. Okay, and so why are we getting this? So we have yes, no, and no. Okay. Okay, now to sort this, I can simply swap 2 and 6, 6. So this array became, I mean, I had this array 662, and I can just swap these two elements. So why is it not getting swapped? So when I had I equals 0 and j equals um, if array when I had I equals to 0, 0, 1, 2, let's say print I and j. What am I even getting? So when I was 0, j went till only 1. Why is that? Let's go till n actually. Okay, I think it is because I am only considering the adjacent swaps and not let's make there this n plus 2 and let's go till n minus 2, and now we are getting no, no, yes. uh, it's still not getting swapped. I mean, if this is the case, then I can simply say let's just go from I plus 1, not I plus 1, I plus 2 to n. Okay, if a of array of j is greater than array of I, let's just swap them. So array of j comma array of I is equals to array of I comma array of j, and if I do this I will get a yes. Why is that? So now I am getting print I comma j. So I had 0 and 2, and let's say something like g. 662. I think it should be the the different case, and now we are getting a yes. So let's remove these, and okay, okay, let's try to submit this and see if it works. Python 3. And we did it in big of n square. There might be some better way to do it. Okay, we got a wrong answer. Now why is that? I mean, I will have to test it on some arrays now. At least it didn't give me a TLE, so I know it can work in big of n square now. First I sorted the whole array. Then I said if array of I, I mean, I should go from 0 to n only, I think. And now I can say if j minus, let's say if absolute value of j minus I is less than 1, less than equals 1, then continue. Okay, why am I getting this now? Let's just print I comma j, what we have. And after this, let's print my array value and my b value. So my array value is still 6, 2. Didn't we manage to get 0 and 2? Yeah, this should be j minus I, not that. And we are still getting this. 0 and 2. Okay, I think this is a complex case, but I mean 0 should be if array of I is greater than array of j, then only I have to do this, otherwise I can't actually do it. Why will this give me a wrong answer? I'm not sure why this is giving me a wrong answer. Hmm. I'm not going till n. I'm going till n, so it doesn't actually matter. Um, for j in range I to n, that is also correct. If array of I is greater than array of j, I mean I should, oh, I think I should take consecutive from 0 to n minus 1, actually n minus 2. I should try to see that if array of j is greater than array of j plus 2, then I can swap them, because let's go till n minus 3, because n minus 3 plus 2 is n minus 1. So let's go till n minus 2. I don't know. N minus 3, then n minus 2 plus 2 is, yeah, I think this is the case. If array of j is greater than array of j plus 2, then I want to sort array of j plus 2, j plus 2 and j. So this is causing me errors now, because it is giving me a no. Now why is that? Uh, I mean, did we even swap something? Print j comma j plus 2. Print j comma j plus 2. Okay, we straight away got a no. So it is never entering this case. Now because why is this not even entering? Let's go till n minus 2, and now we are getting a yes. I think this should work now. Now it passes. I think this is the correct code. Let's try to submit this and see if it works. Okay, we still got a wrong answer. Okay, now let's think about this. I mean, if I am at minus 2, if j plus 2 is equals n, then I should say continue, because then I will be out of bounds. Otherwise, I am simply swapping the alternate integers. And now since I can't swap, I think this should work. Why is it not working? Okay, let's try to see in which test case, for which test case this will fail now. Okay, let's say we have some array a1, a2. Let's say we have 1, 2, 3, and we want to, I mean, I can swap these. So if I had 3, 1, 3, 2, 1, I can make it 1, 2, 3. So this becomes sorted. But if I had something like, if I had swapped these two, so If I add 3 1 2, then this array is not sortable. So basically I can divide this into two arrays alternatively, because these arrays, these can be sorted, and now these can be sorted, and when I merge them, so first I can do is first I can sort the alternate odd ones, and then I can sort the even ones. Then I have to say that okay, at any point of time, I mean, let's just do that. Why not? So this will be an n log n time complexity. So let's say a is equals to this and b is equals to this for I in range n. If I and 1, a dot pushback, a dot append array of I, else b dot append array of I. Okay, so we have these two arrays. Now first I'm going to say a dot sort, b dot sort for I in range n by 2 now. I mean, it might happen that one has more elements. Let's say if I had some odd length, then one will have the first one with the even one will have more length, right? So I can say for I in range len a, okay, if let's go for minimum of len a comma len b. Okay, now I want my first number, since it has more numbers. So if a of I at any point of time, if a of I is greater than b of I, print no, return, else I will print yes. I think this should work. So we are getting the exact opposite, so this should be no. I think this should be less than sign. Let's try to submit this and see if it works. I wasted so much of time on this problem. Okay, I'm still getting wrong answers. Why am I getting wrong answers on this easy problem? I mean, how many people have actually solved this? Okay, so my rating is going down today. Okay, after sorting, I can merge them, right? So I can say for I in range n, okay, uh, I can merge them alternatively. So okay, now to merge them alternatively, I can say okay, while a array dot append a dot pop. I mean, let's say while b and array dot append b dot pop. Okay, let's pop the 0th index only. Now what? Once I've done that, let's print array. Oh, I think I made some mistake. It should be while a, and let's actually not do this. So we have 622, and I think array dot append b dot pop. So it becomes 626. If you can say if array equals sorted array, We are still getting something. I mean, I think this will surely give me a TLE, but I think I will have to try this now. Why am I getting wrong answers? Am I missing some sort of edge case? AI is equals to 1 and BI is equals to. I can. I think I am missing some sort of edge case. Let's say I have A1, A2, A3. So I can swap A1 not with this but all the others. I can swap A2 not with this but all the others. So why did the bubble sort code work? Let's read the problem again. If they are not adjacent, that is, you can pick any two indices, swap them, and using this operation finitely many times, possibly 0, is it possible to turn A into a sorted array? Okay. So when will I never be able to sort the array? I will never be able to sort the array if the smallest element is on position 2, right? So first I should see mn is equals to -1. Let's say mn is equals to min of arr. Okay. If arr1 equals mn and arr0 not equals to mn, I mean if the frequency of the minimum array is not equals to, I mean if the minimum of the element cannot come at the starting index. Let's say I have 3, 2, 4, 5, 6 and so many things. Then there are, I mean I can swap this with this and I think this will always be a yes. I mean there are this will always be a yes except the case when the length of array is 3 and I can only swap these two. Otherwise, if I have something like 1, 2, 3, 4, I can swap 1 and 4, I can swap 2 and 3, then I can swap 3 with this. So there is only one case if n not equals 3. So I can say if n not equals 3 or if n is greater than 3, then the answer is simply always a yes and return. Otherwise, let's say if equals 1, if n equals 1, uh, also if n is equals 1 or n equals 1, then on the answer is yes. There are only two cases. If n equals 2, if arr is equals, then let's print yes. Okay. If n equals a 3, then there is a case that arr0 comma arr1 0 2 equals to maximum of these two, minimum of these two and maximum of these two, let's say. And the same thing, if arr equals this, then let's print a yes, else I am simply printing a no and return. I don't know why I wasted so much of time on this. This was an easy problem. Yeah, I think I used too much of brain on this. Oh fuck. Sorry about that. I think I made a huge mistake spending so much time on such an easy problem. Okay, let's move on to the next problem. We have uh, such a big statement. You recently read about the Caesar cipher, one of the first and the easiest to break cryptic algorithm known. Since it is very easy to break, you decided to improve it by building a light version of it. Here is a modified algorithm. Suppose we want to crypt a plain text p of length n. First, to generate a secret cryptographic key k um, which is an array of length n. Then for each I from 1 to n, you perform ki, Caesar 3 shift on character pi. It is defined as replacing character with the third next character in the English alphabet. Okay, this is done cyclically, which means that the character A is the next character. Okay, yeah, okay, doesn't matter. Survival. Let's denote the cryptic encrypted ciphertext of plaintext P as okay. So, for example, if K, then EK pass equals to fail. So, I think this is a problem of binary lifting, is it? Because I think K will go till 10 to the power 9. No. Okay, so it is going till n only. Let's note the cryptic. I think I can still do it in n log n time. Doesn't matter. So it is given that from A to G, ABC, key is equals to. Okay, so we want to find the key. Like what is the how much distance is between them? Okay. Okay, I think this is pretty easy. Like okay, if I know that G is greater, if G is less, this is pretty easy. Let's see, let's do. I think I will do it in C++ this time. Okay, so int n, cnn, and string a comma b, string, okay, string a comma b, cn a and b for I in range. Let's initialize my answer as n. Okay, now I need to check if a of I, first of all, if a of I is greater than b of I. I mean, if or I mean, we only have two cases, else something, or I mean, there are three cases actually. Else, first is if this, else if we have a of I is greater than b of I, and we have an else case. So if they are equal, I don't need to do anything. So the answer will simply be 0. Otherwise, what I have to do is so if a of I, if it is greater, then I can simply say answer of I is equals to, first I have to convert it to an integer, then what? B of I minus a of I. So the characters are integers. Otherwise, I have to say, okay, now if I am going from, let's say I have to convert A to a B. Now I can't go in reverse order, right? So I have to first convert it to a Z, and then from Z I have to again convert it to A. I think this will be equals to B minus A, the character that I should get. So 26 minus this, because A plus 26 equals to A. So 26 minus, okay. I think I get it. So the answer will be equals to, answer of I equals to 26 minus AI minus BI in a colon. And in the end, for int x in answer, let's see out x with a space. See out endl. And we are getting 6022. Let's see why. First we have A and G. 0 is okay. Then we are getting some wrong answers. First, why are we getting a 6? Let me use my debugger. So we have debug int of this number. So first we are getting a -6. This means why is it equals to -6? I mean, G is 7, A is 1, so we have 6. But A, B, C, D, what? Wait a second. Okay, I think I misunderstood the problem. KI is the third shift on PI. That means let's denote an encrypted cipher character on plain text key as EK. So from 40, after a long time you forgot what K was. What is the third shifted? Replacing with the third next character in the, okay, so we are replacing with the third next character and not the next character. I think I can do this easily in big of n square, but we have to do it in n log n time, and that is the task here. I think I should do this using binary lifting. I mean, there will be cycles. There will be many cycles actually, and every number points to the next number. But that will, I think it will be overkill. Should I do it using binary lifting? Ah, I don't know what to do. Okay, let's say, I mean, if I'm at A and I need to reach at, uh, I'm at 1, I can go to 1, 2, 3, so A, B, C, D in one move. Then I can go to C, D, E, F, and D, E, F, G in two moves. Okay, so this cost me one operation, this cost me one, one. Okay, so from here I can go to G, H, I, J, K, L, M, G, H, I, J, D, E, F, G, G, H, I, J, K, L, M, N, O, P, right? Q, R, S, T, U, V, W, X, Y, and Z, A, B. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So to make A to B, I actually need 9. And from B, C, D, E, F, G. I think I can make a cyclic like this, and then I can first store the minimum distances of every number. I think I can get the shortest path. I mean, there will be at most 26. So what is 26 cube? I can do an all pair shortest path. So what is 26 into 26 into 26? Not many, only 17,000 operations. So I can do an all pair shortest path using Floyd Warshall. And I think this will pass. Then I can find everything in big O one time. Yeah. So I think I will do that. So first thing I will need is the integer array. So A is pointing to this, B is pointing to that. Can I do it using singly linked list? I can do it using singly linked list. I can run a DFS and then find the answer. Yeah, I think I can run a DFS. So let's say int vector int. This will be my graph. Okay. So let's say graph dot resize 26. Okay. For let's say we have this, and now I want to run the DFS function. So let's say void DFS, and my starting node is obviously equals to 1. So I want to run my DFS from 1 because 1 will be my I mean 0. Okay, so from 0 I can go to that let's say visited of let's say visited of node equals to true, right? So visited of node equal to 2, and now I can go to what? Okay, I think let's say not DFS, let's say string X. Okay, and the starting string is A. Okay, and from A, let's say char cur equals to capital A. Okay, while not A, I want to go to D, right? While cur not equals to x of 0. Okay, cur uh, plus equals to 3. Just see out cur. What do I get with a space? What will I get if I do this? I think it will go for an infinite loop. If cur minus a greater than 26, cur minus equals to 26. If I do this, I mean I'm adding cur, that will give me a time limit exceeded. This contest is not going well for me. So we got to G and so many different characters. Y. Then if cur minus a is greater than equals to 26, then I will simply say so we got so many different characters. From Y we went to this character. Now why did we go to this character? Okay, so from Y we went to B, C, D, E, F, G, H, I, and then we got to 6 again. I think I made it x plus equals to cur. So let's say my string is x here, and then let's print cout x with a space. So we have this x, and now I can simply first store the index of every character. So I mean I will get the value to reach from A to G. I think I get it now. Now I can store the value. So let's say vector int index of let's say 26. Now for char I in x, what I can do is index of I minus a equals to not this. I can say for I in range 26, because this is I think x dot length is 26, right? Uh, yeah, let's go till 26. Let's say index of x of I minus a equals to I. Okay, Okay, now we have these two integers. What I can do is answer of I is equals to index of uh, b of I minus a. Okay, so the uh, index to reach this minus index of a of I minus a. Let's say the answer is this. Hmm. Now what I'm getting? I'm getting index of b of I minus index of a of I as this. Now let's see. Let's actually remove this from here. Um, okay, I'm getting very wrong values. First I want to do is debug index. So index of a is 25. Now this is wrong because index of a should be, let's go till 25 only then. So index of a should be 0, yeah. A, B, C, D, E, F and G. So G is 1. I doubt that. Okay, so if I'm starting from A, I can actually never reach this number. This, I think. Yeah, if I'm starting from A, I will never be able to reach A, B, C, D. I will never be able to reach D. So, is there an answer for -1? Like output, print n space area representing lexicography's smallest key such that E of P equals C. Okay. Yeah, I mean it was given and we want to find the key. Okay. So the answer will always be possible. And if I'm starting from A, if my first starting letter is A, then that means I am here. Okay. To reach from A, if I want to reach this, I will need 17 moves. Like if I'm at A, I want to reach G. A, B, C, D, E, F, G. It is telling me I can do it in simply one move. What? I need to reach D first, right? So I'm going to say, yeah, I think this is more correct. So I was at A, I wanted to reach D. So it will take me actually two moves, 0, 1 and 2 for D. Okay. Now to reach from Y, I want to reach C. So the distance for C, A, B, C is 18 and from the distance for Y is 8. So Y I will reach first, and if I want to reach, and from there, from Y I want to reach C. So I will go from Y. So the cost of reaching Y is 8. Cost of reaching C is 18 and the answer is minus 10. What was the original answer? Expected answer is 16. I mean, can I make this for all the integers? Let's say this x is, can I make a map of char, comma, vector int? I mean, I can simply make a map of this where the starting element is that. Yeah, I think I can make a map. Okay. Okay. So what I will do is for I in range 26. Okay. And let's say char cur is equals to a plus, not a, I mean a plus I plus 3. Okay. And let's say the string x that I have, I don't even need it. So let's say int that is equals to a plus I. Okay. Now what I can say is, first let's generate everything. So while cur, I can move this up. So while cur is equals to a plus I plus 3 not equals to x of 0. Now once this is done, I can remove this. Say okay, let's say we also have an index array, comma 0, and now for I in range this, and then I can say mp of the character. So a plus I equals to index. I think I can do that, right? Now I can say mp of the character, so a of I minus b minus a, iska, I want to get the b of I minus a. Okay, we are getting a sectum. I think I don't need to do it right now. I think we are getting a sectum for this. Why is that? Let's not, for now let's remove this, and let's say debug x and debug. Okay, let's say debug x and break. Okay, we had x equals a. Now what if I start from 1? So if I'm starting from 1, I should start from x should start from I mean b c d e. So where is the b? X doesn't even have a b. If I start from 0, so I'm starting with 0. Yeah, that is correct. I think this is because this is a string, not a character. Okay, I think this is correct now. Let's break out of this loop, and okay, we have this. Now what can I do? Like for A, B, C, D, E, F, G, I have calculated everything. But there is one more thing that I'm doing some wrong things here. U, why am I getting this? This will lead to a segmentation fault. X plus equals to current, okay, that is good. X plus current plus equals to 3. If current minus A is greater than equals to 26, then I'm subtracting it, that is correct. Uh, where am I getting special characters? I want to debug that. So for x is x, y, z. So 26 minus 3 minus 1, 22, right? And let's break out of this loop. And here also I should say if current greater than 26, current, the same thing that basically I did here. I should also write this here. I think now it will work. From 0 to 26, I have gathered all the information that I need. Okay, let's try to run this and see how it goes. So we are getting segmentation fault. Now why is that? Mm, okay, 0 0 0, that is correct. Now MP of A of I minus A, I think because I made a character like that, A of I can simply say A of I. I don't need to do that. Yeah, I think we are getting correct answers now. Let's remove this debug statement to save some time. Yeah, it passed. Let's try to submit this and see if it gives us a correct answer. C++, submit. Yeah, correct answer. Let's move on to the next problem. Some error occurred. This is Frequal. An array A of length n is called Frequal if for each I the frequency of AI equals the number of its positive divisors. Okay. For example, 281888882 is a Frequal array. 1 has one divisor, 2 has two divisors, 8 has four divisors, while n is called Frequal if the frequency of AI equals the number of its positive divisors. Okay. So I just need to calculate the number of positive divisors, and then I need to check if the frequency, if it denotes the number of distinct elements in A. Okay, you are given integer, find any frequal array A such that fa is as large as possible. Okay, so the number of distinct numbers is as large as possible. So I think to make it as large as possible, fa, I should just use the prime numbers maybe, because prime numbers only have two. Yeah, I think I should just use the prime numbers, because if I have 8, okay, this one, this is using, I want to have 8 elements. Okay, okay, yeah, I want to have any 8 elements. Now, okay, let's try to think about this. We have an array given in defined array. Okay, I have to, if I'm given, I have to take p like that. Okay. Okay, I mean, if it is, I mean, n can be either a prime number, an even number, or 2n plus 1. So if it is, I mean, whatever the case, I can just choose n primes. What is the value of maximum value of n that I can get? 2 into 10 to the power 4. So I just need to get the prime numbers in this range, and then, like, if I have n equals to 8, okay, so I can choose 4 prime numbers like 2 2, 3 3, 5 5, and 7 7. So this will give me a correct answer. So I think it is an easy problem. Let's just try to solve this. I mean, I can do it in Java, Python. Let's try to do this in Python. Okay, so first I want to get the prime numbers, right? So let's say primes is equals to this, then we check is equals to uh, let's say false for I in range. I mean, I am doing a linear savior, so let's say capital N is equals to int 2e5. I think it was 2e5. Okay, it was 2e4. But I will need numbers. I will need some. I will need prime numbers more than that, right? So I want to know how many prime numbers are there. I think I will do it by trial and error. So I at least need 2e4. So 2 1 2 3 4. Basically 20,000 by 2. I at least need 10,000 prime numbers. So my 10,000 prime number, I don't know where it will occur, but let's go till 10 to the power 6. I think 1 is 6. That is the ideal case for I in range n. Okay, and for I in range capital N, and let's start with 2. Let's set this to true. If check of I, I'm going to say first of all primes dot append I, and for I in range I n comma I, check of I equals false. Okay, now I have many prime numbers with me. Okay, just for I will say, okay, len primes. Okay, 7 8 4 1. I mean, I have 78,000, which is too much. I don't need to go that much. Let's go for 10 to the power 5, and this is too less. Okay, let's go for 2 into 10 to the power 5. I think this is optimal. Um, let's go till 2 into 10 to the power 5 only. Now, first I need to get an integer. Okay, now if n and 1, answer is equals to this. If n and 1, then answer dot append 1, because 1 has only one factor. So and n minus equals 1. Okay, so if n was odd, that case is taken. Now I just need to get the answer is equals to answer plus primes start to n minus 1 plus primes start to n minus 1. Let's say print answer. What will I get? Okay, so we had 2. So I wanted two numbers. So 2 2, yeah. 4 8, 1 2 3 4 5 6 7 8. 1 2 3. I think I made a mistake here. I should go till n by 2 and n by 2. Yeah. 1 2 3 4, 1 2 3 4. Yeah, I think that is correct. Let's just put a star here and remove this len primes. Let's try to submit this and see if it gives us a correct answer. Yeah, our solution got accepted. Let's move on to the next problem. Okay, split and maximize. Okay, chef has an array A of n positive integers. He can perform the following operation at most once. Select an index I, an integer. Select an index, sorry for the background noise. Select an index I, and an integer k greater than equals to 1. Select k non-negative integers x1, x2 till xk such that, okay, sum of this thing, select k non-negative integers this such that sum of this is equals to a of I. Erase ai from a and append this to a. Okay, okay, erase ai from a, and we can append the powers of 2 to a. Okay, note that x need not be distinct, xi need not be distinct, so xi can be equals to 1 also. Yeah, chef wants to maximize the bitwise OR of all the elements of the array. Okay, and he can perform this operation only once. Yeah, so how will the bitwise OR increase? I need to think about it, right? Okay, let's try to see. AI is going to the power 60. So if you are doing it in C++, make sure you are using long, otherwise it will give you some, it might give you some errors. Okay, so first I have an integer n and a. So I have integers n and a. Now select k non-negative integers x1 till xk. So I can select x1 till xk. I mean, let's try to understand this with test cases. Let's say we have 5, 7, and 7. And since this is a bitwise problem, I should write this in bitwise like that. So it will be 101, 111, and this is 111. So clearly the maximum I can get if I do a bitwise OR of all these numbers, it is 111. I can't go beyond this. So I think the answer should be 7 in this case. Yeah. And again we have 557. What is this? I don't know. Let's say we have 1, 2. I mean, I don't know what's the point of this. Test case 1, we can select I equals to 2. 7 can be represented as 111. So we can erase. What does this guy wants to do? I don't know. He wants to increase the bitwise OR. Bitwise OR was already equals to 7. If we had 557, I mean 7 has all the bits set to 1. So we don't need to worry about it. I think the answer is simply the bitwise OR of all these elements. Why am I even worrying about this problem? But this is too easy if the answer is that input a is equals to list map int input dot split. Now let's say answer is equals to 0 for I in a. Answer is equals to answer or I, because even if I split it, do we want to minimize it or maximize it? Can you help him at most once? Bitwise. Okay. Sorry. I read it bitwise OR. This is actually bitwise XOR. So that is a different case. So we have 101, 110, and 111 and 111. So clearly, since I want to maximize, okay, this is odd, so this bit is set. This is even, I want to reset it. This is odd, so this bit is set. Now, what can I do? Okay, we have 2, so we have 2 to the power 0 here, and that bit is unset. Okay, uh, can I write 2 to the power 0 as a power of 2? What did this guy do? 2 to the power 0 can be written as 1 plus 1 plus 1 plus 1 plus 1. Okay, which is, I mean, I can write add something to this. So yeah, I can set this. Can I say to the power 2? If I had like this, then how many ones is that? I mean, I just need to remove one of the, if this whole is empty, I mean, if for every I first need to count the number of times that occurs. If it is occurring even number of times or 0, I want to try to make it equal. So from somewhere I will be subtracting something. Like obviously if I have like 1 2, so if I have a whole, like let's say how many numbers are there, so 2 to the power 0 I have 7, 2 to the power 1, let's say I have I get 2 to the power 1, 1 as 8 times, and 2 to the power 2 I get some uh, let's say 8 times only. Can I do something to decrease this by 1, and then I get a 2 to the power 2, which is equals to 2 to the power 1 plus 2 to the power 1, right? So I can easily add this thing to some sort of even number, some even number before. Okay, I have 2 to the power x, which can be written as x by 2 plus 2 to the power x by 2. Yeah, yeah, I think let's get the maximum bit that was set. If it was even, I mean, obviously, if it is 0, then it doesn't make any sense. But if it was, if the highest power of bit was had an even power, even number of times it occurs, then I can subtract this and add it to the next one. Yeah, I think I can do that. Okay, I think I have the solution. Let's first take the maximum power of bit that is occurring. So, okay, what is the range that I have? We have till 60. Okay, so I think my solution will work in nlog in time. Yeah, that should pass the constraints. Let's do that. Uh, let's say count is equals to 0 for I in range. Let's go for 61. Okay. Now for I in range 61, for j in A, if j and 1 less than I, count of j plus equals 1. Okay. And for now, let's keep it till, I think 2 to the power, let's keep it till 6, and let's see what is my count. What am I getting? Count of I plus equals 1, sorry. Okay, so we have this. Now, I mean, I will take the power with maximum value. So, first of all, I need to get the, if they are 1, then I don't need to do anything. Okay, so I will traverse in reverse order. Okay, so let's go for reverse order for I in reversed range 61, because I said okay, let's go to the 61. If the if and I want to go I want to start from 0, because I don't want to process it for the last element. Okay, if I if count of I and 1, so if it was already odd, let's continue. If it was 0, or if count of I equals 0, or count of I was an even number, then let's move on, doesn't matter. If it was an even number, like we had a 2 here, so I want to handle this case separately. Okay, let's say n equals to 61, because I don't want to make errors. Okay, and for now I will keep it equal to 6. So we have let's also print my count value. Okay. So we have this. Now if else case, like if it was an even number, then I can say count of I minus equals 1, and count of I minus 1 plus equals to 2. Let's print my count value. So it becomes this. Now, okay, once I have this, now I can simply do this again, do this whole thing again. Or maybe I can just say answer equals to 0. uh, if I will have to split this now. So let's continue. If this is the case, you check equals to true now. I don't think this is necessary. So let's remove this. So if count of I was equals to 0, then otherwise I'm going to say answer is equals to answer or 1 less than I. Okay. Okay, so we have this. Let's try to see if the solution works. Okay. Why didn't I receive any output? Let's print answer. Okay, let's try to submit this and see if it gives us a correct answer. Okay, we are getting a wrong answer. How many people have actually solved this problem? 135. I think we can still do this. Okay. But only 49 minutes are remaining. I think I can close. Okay. I want to maximize it. Like, can I borrow something from someone? There will be some excess values, right? This is tough. I can maintain some excess values. So let's say excess, okay, because I only need very few things. I don't need too much, right? So I can go in reverse order, and if my count is 0, obviously I can't do anything about it. If it is even, if it is an odd number, then I will say excess, I can say excess of I equals to count of I minus 1. So this was in excess, and I will say count of I equals to 1. Okay, so my excess value was this. Now, so this is something that I can borrow from up, right? But on some conditions. Like if I have 2 to the power 3 7 times, I can say this is 6 excess, 6 in excess. So can I get 2 to the power 0 from this? So this is equals to 12 times 2 to the power 0. So this is not actually worth it, but I can also say uh, not 12 times, it is equals to actually uh, if you have 2 to the power 3, it is equals to 2 to the power 3 minus 1, 2 plus 2 to the power 2, and this is equals to the power 1 plus 2 to the power 1, right? So I can say 2 to the power 3. I can get 2 to the power 2 plus 2 I can either get 2 times 2 to the power 2, if but this is not useful, right? But I can get 2 to the power 1 plus 2 to the power 1 from here, and then 2 to the power 2. Yeah, I think I can get that now. Okay, so if I have something in excess, I can propagate it. So what I need to do is if I have something in excess, like okay, I had this in excess, right? So I will propagate it to the next element at least. So I will say, okay, count of I equals 1, answer was set, okay, and what I can do is at least propagate my answer. So excess of I can say count of I minus 1 plus equals to, so I'm keeping one for myself and I'm sending others to the next element, okay, if I and 1. Otherwise I will say minus 1 and when 2 times that whole thing, okay. So now I have an odd number with me, and now I can say, okay, let's do this again. And if I run this again, I think this will give me a correct answer. Okay, still we are getting some wrong answers, but I think this is better than previous. Okay. Uh, when we are here, I think I forgot to make this equals to 64, 61. That is why we got a wrong answer. Otherwise, my solution was correct. Yeah. Sorry about that. Now let's try to submit this again and see if it gives us a correct answer. Oh, okay. Okay, so we are here now. Answer is 0. Answer is equals to answer or 1 less than I. If it is and 1, then I will say, okay. Uh, like what is the value of a of I? 2 to the power 60, right? So the sum won't go too much. Yeah. 2 times count of a of I. I think this value might become too much to handle. That might happen, right? Okay. So we went till 61. Will this code, where does this code actually fail? I want to get that test case. Okay. So we have some numbers. I'm going in reverse order. I'm trying to set the maximum bit. I think okay. I think can I mean if I have something in excess, then I can probably make it in reverse order also, right? Let's say I have maximum some many ones, right? Now I can combine these ones to make it equals to a power of 2, right? Okay. First I want to get what is the maximum power of 2 that I can get. If I have some extra numbers like right, like if I have some extra numbers, I think I should try setting bits to 1 from left side instead of going from right side. Okay. I don't want to go in reverse order. So let's go from 0 to n, obviously, till actually n minus 1. Okay. So if my count of I equals 0, then there is no point in doing it. Otherwise, I want to set this and let's say count of I. If count of I and 1, then I can say count of I plus 1 and I am adding it 2 times. Okay. Else count of I minus equals to 1, count of I plus 1 and count of I plus 1 obviously. and now we are getting a very huge answer. Now why is that? Because this should be equals to by 2, right? I'm keeping 1 for myself, and the rest of it is going to the next number. So I have to say, if it was if I have something even, then I can't just send something outside, right? I have to borrow it from the next, uh, what should I say? I have to borrow it from someone else. Okay. So if the current one has an even number, then I have to borrow it. Like I have to get it from some uh, future one, right? Now how can I do this? I think I have maximized my answers that I could have from this code. I mean, this is not completely wrong, right? Uh, but there is still some possibility that in the end I will have so many ones. So the count of those ones I can add it to some power of 2, I think. So if count of 0 and when the this is correct, let's say count of 0 minus equals 1. So I will get the count of ones that I have, and this will be some power of 2, right? Uh, so how do I check if it is a power of 2? If it is greater than, if it is just greater than some power of 2. So what I can say is, while count of 0, I want to check if it is a power of 2. So uh, I want to get the maximum power of 2 that I can get from this number. So I can write a function for that. Def get max power of 2, get max power of 2, and n, let's say c equals to 0, while n is equals to n by 2, not n by 2, n by 2, and c plus equals 1. Okay, so if it was 1, so if n was 1, so okay, then we get a power of that, and then let's return c. So if it was already 0, then I don't know. If it was 1, then okay, then also we will return 0. And if it was at least 2, then we will return, then 2 by 2 is, then we will have to the power 1. Yeah, I think this is correct. So I will get the maximum power of 2 that I can get from this. So answer is equals to answer or 1 less than get max 2 of count 0, and let's print answer again. Okay, so we're getting 15 now, which is incorrect. I think I made some mistakes here. Okay, negative number shifts I can't do. So let's say maximum of c comma 0. Now there is also one thing that, okay, if it was an odd number, then I want to use this and do this. Otherwise, I don't want to do this. Okay, Yeah, if count 0 greater than 2, then only I want to do this, otherwise I don't want to do this. Let's try to submit this and see if it works. Okay, still we are getting some wrong answer. Okay, greater than equal to, maybe. If count 0 and 1, then what I can do, it doesn't actually matter if it was odd or even. I can just try and get the maximum power of 2 that I need. Like if I have some huge power of 2, then I can just try to first eliminate them, right? So I can say while, before doing this, like while count of 0, okay, so I want to subtract uh, 1 less than j from count, and set answer is equals to answer or 1 less than j, right? Because I mean, to make several ones, it will cost me 4, so it will be even number of ones, so that shouldn't cost me much now. While count of 0, I think yeah, I think I have solved it finally. Let's try to submit this and see if it works. Okay, we are getting wrong answers. Okay, let's again go in reverse order. Okay, and I want to try for to go in reverse order till this number. Okay, okay, if uh, let's go in reverse order like this. So this is the maximum power that I can get from count 0. If like 2 to the power 2, so I can make 2, so let's do a plus 1 here. Now if count of I equals 0, then I can say count of 0 minus equals to 1 less than I, first of all, and answer is equals to answer or uh, 1 less than I, obviously, and count of 0. And now let's print answer. Okay, now it ruined my solution. If count of 0 and 1, then answer is equals to answer over 1. Yeah, let's try to submit this and see if it works. I mean, right now I don't even care if I get a TLE. I just want to uh, at least have the correct answer. Now, why is this giving me wrong answers? First of all, I have to transfer everything to the power 0, which is wrong, I think, because I can't maintain a sum which is so much. Okay, let's try to do it by some other approach now. Let's say I have 2 to the power 1, to the power 0, 78 times. Okay, and if I only have this, my first goal should be, do I, if I don't have to the power 1 set, or I should just see what is the maximum. I have 64, right? So I can set 64. So I will do 78 equals to, first of all I should subtract 64 from this, and to the power 2, to the power 4, to the power 5, to the power 6, right? And set this to 1 first of all. And now, I mean, what was given in the question? I can split it into sums. Yeah, actually, like this is equals to how many 2 to the power 0? I mean, I think it will give me, the problem is that I might get a space error. Okay, my rating is pretty much the same for this contest. The problem is I want to split this number 2 to the power, whatever the s is. I mean, I can write it in some binary form, right? I have this now. This is contributing here. Now 2 to the power x is, if I, even if I take the sum of all these, it will never overcome this. But here is the problem, that if I have so many of these values, if I take only one, that will never be sufficient. But if I take many of, like if I have two times this number, then I can probably make one more, and that is the case. So I think I should first try to see how many numbers that I have. I mean, I want to increase the XOR. Uh, this is tough. I mean, really. Okay. Should I try to build this from left to right, or should I try to build this from right to left? That is also the case, and I also want to find out. Okay, let's say I get 2 to the power 0 two times. Now I have one choice. I only have one choice, that I should neglect this and make 2 to the power 1 at least, because that is the maximum that I can get. Now, how do we even go about this? How much time is remaining? 34 minutes. And 200 people have solved this. I think I can. Let's see. With a 9.5% accuracy. This is what I don't like about Codechef. But this is a good problem, I think. Because to make it distinct, for example, it is allowed to write 2 to the power 2 as 2 to the power 1 plus 2 to the power 1. So I don't want to split it downwise. I want to split it. Let's say I get 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6. Uh, and I have some numbers here. Okay, I have written everything like this. Now I only need, do I even need numbers greater than 1? I mean, I will say, okay, let's say if it is even, then I can't do anything much about it. I will just divide it and add it to the later that thing that I can get. If it is an odd number, then I will keep one for myself. And yeah, I think I'm getting it now. First thing that I should do, I mean, this code is pretty much correct. But before doing anything here, what I should do is, after counting this, I should traverse in single order, okay, for n range n. Now, if count of I equals and 1, Then I will say count of I plus 1. So let's go till 1 less than index, plus equals to 2 times count of I plus 1. Let's say count of I mean I want to set count of I equals to 1, so count of I equals to 1. Okay, and I can say count of I plus 1 equals to 2 times, not 2 times, divide by 2. So let's say count of I minus 1 divided by 2. Okay, so plus equals to this value. If it was an odd number, that is good. Otherwise I have to do this recurrently. Okay, now I can do this whole thing again in this fashion. I think I should just, for safety purpose, I will go till to the power 62. Okay, okay, and now I am doing this thing in the reverse order, and at last I should check if count of 0 and 1 answer is equals to answer or 1. And now we are getting some wrong answers. Let's see why. uh, I mean there should be an else case also. If it is even, then I should set count of I equals to 0, and before that I will say not minus 1, just say count of I plus equals to this value. And now we are getting something completely different. I will try to fix it. Okay, if count of I was equals to 0, then there is no point, just keep traversing. Otherwise I will first set this value, and count of I and 1, if count of I and 1, let's try it for 6 right now. Okay, for this value what do we have? Let's first print the value of count here. I mean we had values till 2 to the power 3, not 2 to the power 2. After doing this step we had values till k, like 2 to the power 2. Why did we stop here? I should have let's actually print this sequentially now. Okay, so we had this. Now first thing that I did was I increased this count by 1. So 2 of it will become 1, so this will become 3. I will keep 1 and increase my this, so this will become 2 now. Yeah, I think I can do that now. So the answer should have been 19, I think. Yeah, this is correct. So why is this not allowed in the question? I can split, but once I've split, I can't merge. You are given two non-negative integers x1 till xn, and if it is possible, then I can split them and erase a from this, and I can add this. Now notice that it need not be distinct, and okay, I can further split them, but I can't merge them. So this is actually something I'm doing is called merging. So I can't merge two small powers to make a bigger power, but I can do the reverse. So this step I should not do. So why is it giving me wrong answers? I'm not sure why I am getting wrong answers now, because Else what I can do, if it was greater than count of I minus equals to 1, count of I minus 1 plus equals to 2. Yeah. Okay, so now it became an even number, and so you are doing this. Yeah. I can't think of a test case where this will fail. So why am I getting wrong answers? First I tried counting. Okay, I think it was because I did not put 60 there. I mean, this is correct, but we are getting some wrong answer. I think there is some corner case that I'm missing. Okay, AI can be 0 till to the power 60, and there are so many numbers. Yeah, the sum of n over all test case won't exceed. There is this thing that if I keep multiplying, like, okay, then this number will become really huge. So what I can do is simply maintain count as 0 or ones. Uh, Nothing more than that. If I have something in excess, like if count is equals to, if it was, I can maintain 0, 1 and 3 only, because I think this is a really large test case for which this is failing. Otherwise it is correct. For which test case is this failing? That is, it's a count of I minus equals to 1, count of I minus 1 plus equals to 2, count of I minus 1 plus equals to 2 times count of I minus 1. This is also correct. So I'm subtracting, increasing this value. If I'm doing this step, basically if I have even numbers, basically I can never set the power, set that power of answer, I think. Yeah, I think this is where I was going wrong, and now it should work. So it's taking so much of time to give me a wrong answer again. Uh, okay, I forgot to comment it here, and now we are getting some wrong answers. Why? Because I can subtract 1 from here, add 2 there. No, this is correct. But let's say I have so many ones that no, I can't recombine them. That is not good. But if count is equals 0, what can I do about it? I mean, this will never be 0 actually, because it is cumulative sum. But if I keep multiplying this number by 2, it will be very huge, right? Let's see what happens if what happens to my count. Let's actually print this count variable. Not count, let's print count 0. If you see, count 0 is very, okay, count 0 isn't very large, like 1, 11, 13. But these are only 3 numbers. If I have one more, then it will be a problem. Okay, let me try and add one more number, then see. That is the issue with this number, because if I add all the numbers till that, it will be stored in count 1. Okay, at least the summation of the array will be stored in count 1. Yeah. Now where will this fail? Should I go till 0 now? I can't go till 0 because there is no count -1. This is tough. I can't even do this in brute force using brute force. How many people have actually solved this problem till now? 285. What if we have a 0? To do a 0 we have, okay. I mean 1 less than 0 is what is 1 left shift of 0 uh, in Python? What is 1 left shift of 0? Okay, I think I missed this. What if we actually get a 0? So we will get, this is 2 to the power 0, but if we have zeros here, can we neglect this? Because we can't actually split it into powers, so I think we can neglect this. Let's see some corner cases. AI is going, I think this is the only corner case that I have not thought about. So when oh, oh, if I have 0, then, I mean, if I have 0, then I'm XORing it with all of the powers. No, I'm not XORing it with all of the powers. Anything XOR 0 is 0. Zeros or 1 is 1. No, I think we can ignore the zeros. Okay. For the third test case, it is beneficial if to not apply the operation. So bitwise OR of 0, 1. So to the power 1 is occurring only 1. This is occurring only once. Once. So if I take the XOR of it, so this should work. Yeah. Even if I split it, I can't make a greater sum. So if I have some numbers which are have some in reverse range, like if I have some odd number of terms, count of I and 1, count of, I'm setting it. Yeah. I can't think of a case where this will be failing. Why? I think this is very close to the correct solution. Uh, should we move on to the next problem? Because I don't want to miss an easy problem just because I'm stuck on some test case. I'm not sure why this is not working. I can't even think about I can't think about a test case where this is not working. I mean, will this work in C++? Maybe it is an error caused due to Python, or have I missed something? Chef has an array. He can, he can only perform this operation only once, not many times. This is the small detail that I missed. Okay, so he can only perform this once. So let's say we have a XOR of all these elements. Okay, if the ith bit of answer is not set. First of all, okay, I didn't read that statement that it can XOR it only once. So let's say we have some answer, and if the ith bit of answer is not set, then I want to traverse in the whole array and check if I can get that equals to, okay. Let's take the XOR. Let's take the XOR of all the elements first of all. When this counting is good, but okay, let's say answer equals to 0. Let's take a of 0, not 0. And for I in range n, actually let's go from 1 to n. Answer is equals to answer XOR I, a of I. So now I have bitwise XOR of all the elements. And now if the ith bit is not set, like I just need to traverse in this array for I in reverse range. Like, okay, if the ith bit of answer is not set, then I want to go in the reverse order. Like, okay, if the ith bit is not set and there is some power at least that can donate, that has the capacity to donate. So if answer and 1 less than I equals 0. So if the ith bit is not set, then I have to traverse, like for j in range from I plus 1 till n. Okay, so traverse like that. Now I need to find at least some power. Like, okay, this is not good. I want you to go in reverse order and do the same thing. Like, let's say, okay, I want you to go in reverse order and I think my code is pretty much correct. There is only one thing that I should be careful is, like, first of all I should calculate the answer, and if the ith bit of answer is not set, first I will calculate like this, and then for I in a, not answer, let's go for I in range n, answer is equals to answer XOR a of I. Okay, and let's say, like, okay, from 1 to n. Okay, and now I have to go in reverse order again. I won't do this. Let's go in reverse order again, for I in range n. Okay, if let's say answer and 1 less than I, then I should just continue. Otherwise I have to break out of this loop. Okay, otherwise I have to check uh, uh, if the count of I, no, I can't actually I can't say that I want to do this. Like, I can traverse for the number which is greater than, and if I have the cumulative sum, like I can have the cumulative sum, prefix sum of all the arrays, that how much this can donate. Like, okay, if I have 2 to the power 0, 2 to the power 1, and so on. Like, if I have 2 to the power 64 so many times, x number of times, and I don't have 2 to the power 32, I can get this it from this, but I will have to check how much this guy can donate, right? 2 to the power 64 is equals to the difference. To make this, it will be huge difference. Like, if it is just, if it is even greater than 1, then I can say that, okay, else let's traverse for I in range, not for I in range, let's say for j in range I plus 1 to n. if count of let's actually not do this whole thing. Okay, if count of j is greater than 1, or I can say if it is odd and 1, okay, and count of j, first of all, that should be an odd number, right, is greater than 1, then that guy generate me so many even numbers, but that will also influence so many odd numbers, right? I think I have an idea. Okay, let's go in reverse range. That is correct. But I only want to do this if I only want to do this once. First of all, if my answers I at bit is set to 0, so I can say if answer and 1 less than I, then equals 0. So if the I at bit was not set, then I have to traverse in the reverse range and I have to do everything again. So till this bit, okay, let's say answer 2 is equals to 0. So this is correct. But now that I have this, I want to have set the ith bit. I will try to get all the support from the forward, the previous ones, and only one of the numbers from the previous can contribute. Okay. So if answer of I and 1, okay, uh, and 1 less than I equals 0, then I have to traverse in the forward direction and get support from at least one of the number that I can get. Now any number will contribute only even parts to this array, I think, right? I mean, okay, any number will only contribute even part to this. So I will say, okay, let's say for I in range, for j in range, uh, let's go from I plus 1 till n. Okay, if count okay, let's say check equals to true. I mean, let's have a check variable which is initially true, and then if I have this, if answer and 1 less than I equals 0, then I will say check equals to false. Okay, now till now I can get something from the further elements, and now I will say if it was odd, and I will only do this else if check, then only do this whole thing and take or, and I think at the end if count 0 answer is equals to answer or count 0 or 1, and then let's print answer. Yeah, I think this should work. So we are getting something different. So we have to debug this now. 577. Let's try for 6 only right now. maybe 5. How much? I think I don't even have time to see how much time is remaining. Okay, only 9 minutes. uh, we are getting 5. Let's print my count value. At every step I want to find my answer and count. Okay, so I'm traversing in the reverse order. First of all, I think there should be answer 2 and answer 2, and I should print my answer 2. Okay, okay, let's try to submit this and see if it works. The contest follows not a I think the contest is over now. Oh, but I will try to upsolve it. Yeah, I almost got the solution and I was not able to submit it. Let's see. I think this solution is correct, but at least I want to submit it once. And I was not able to solve this during the contest, but okay. What is happening? Okay, we are still getting wrong answer. Okay, I was not able to solve this problem, but I don't know what to say. If I will be able to solve it, I will upload a solution on my channel. So kindly wait for that, and I will see you guys next time. Thank you.